Welcome all. Um, in this section 7.3, we are going to be talking about trigonometric substitution to evaluate an integral. So earlier two sections were about um, integration by parts and then trig combinations, trig functions combinations. This is the third section in chapter 7. So here we are going to be seeing how to apply trig substitution to evaluate an integral. So oftentimes we will have expressions involving square root of a squared minus x squared. A is a number. A squared minus x is a variable. A squared minus x squared. In this one, the substitution that we would use is x equal to a sine theta. Then we should remember that theta should lie between negative pi by 2 and pi by 2, both values inclusive. And the trig identity that we would use is 1 minus sine square theta equal to cosine square theta, which is the Pythagorean identity. The next type is square root of a square plus x square, the number square plus x square inside the radical. Then the substitution would be x equal to a tan theta. Yet theta lies between negative pi by 2 and positive pi by 2. Then the identity that we would use in these problems is 1 plus tan square equal to secant square theta. This is another version of Pythagorean identity. Then the last part, the square root of the last type, square root of x squared minus a square, variable square minus number square. Then the substitution would be x equal to a secant theta. Theta lies between 0 and pi by 2, or theta lies between pi and 3 pi by 2. Here, the Pythagorean identity that we would use is secant square minus 1, secant square theta minus 1 equal to tan square theta. So normally we would have only, whenever we have radical expression with the number square plus or minus variable square, or numbers variable square plus or minus number square, and these are the substitutions that we have to make in order to evaluate the integral. So let's try this example. Example integral, evaluate integral square root of 9 minus x squared over x squared dx. So if you look at the numerator is of the form a squared minus x squared, right? So it is number square minus x squared. That's the way the numerator looks like. So if you go by the expressions in the table, so it resembles the first one. So we are going to substitute x equal to a secant theta. If it was a square, here it is 9, which is 3 square. So x equal to 3 sine theta is the best choice for x, the best substitution. Then dx equal to 3 cosine theta d theta. Now let's, as usual, we write the integral I, the integral to be evaluated as I. I is integral of square root of 9 minus x squared over x squared dx. So let's do 9 minus x squared, which is 9 minus x squared, which is 3 sine theta the whole square. So which is 9 sine square theta. So if you take the 9 out, it's 9 times 1 minus sine square theta, just 9 cosine square theta. This is 9 minus x squared. So now if you take the radical, if you take the square root, you have to take the square root here. That will be equal to 3 times absolute cosine theta. Here the assumption is that theta lies between negative pi by 2 and pi by 2. So it will be positive. So it's equal to 3 cosine theta here. So we have, if I substitute all x in terms of theta, the numerator just now we saw equal to 3 cosine theta. Then denominator x squared is 3 square sine square theta. then dx that we have here equal to 3 cosine theta d theta. That will be 3 cosine theta d theta. So now if I cancel out terms, 3 times 3, 9, that is 9 cancelling out. So the numerator is cosine times cosine, so is cosine square theta. Denominator is sine square theta d theta. So this equal to cosine over sine d theta, which is cotangent square theta, which can be written as cosecant square theta minus 1 by Pythagorean identity. Cotangent square theta equal to cosecant square theta minus 1 from Pythagorean identity. This is equal to now integral of cosine square theta. Integral of cosine square theta is negative cotangent theta, and then integral of negative 1 is negative theta plus c. But the answer that we have got now is all involving theta, but the original variable in the problem is x. So we have to bring everything to x. So let's start with the substitution that we have done here, x equal to 3 sine theta. So let's start there. X equal to 3 sine theta, or if I divide by 3, I'll get sine theta equal to x divided by 3. But sine theta in trigonometry is opposite over hypotenuse. So where theta is the angle, opposite side to theta is x, hypotenuse is 3. So if I make use of that, so I will have theta right here, opposite side is x, and the hypotenuse is 3. So this will be 3 square minus x square, this adjacent side, which is 9 minus x square. Now, from this, we have to determine what cotangent is. Cotangent is reciprocal of tan. Tan is opposite over adjacent. Cotangent is adjacent over opposite. Adjacent over opposite. So in this case, cotangent is going to be adjacent, which is square root of 9 minus x square, divided by opposite of theta, which is equal to x. So that will be cotangent theta. Then from the fact that sine theta is x divided by 3, then theta would be sine inverse or inverse sine of x over 3. So if we substitute all these values here, that is cotangent theta is square root of 9 minus x square over x, and theta is sine inverse of x divided by 3. We substitute these two values here in the problem, which is negative cotangent, which is square root of 9 minus x square over x, minus theta is inverse sine of x over 3. Don't forget the arbitrary constant because it is an indefinite integral. So in trig substitutions, usually you need to remember what type is the problem is. Is it the first expression or the second expression or the third expression? Then you're going to suitably choose. Remember that a is a constant and x is a variable. Then after you convert everything to theta, then the answer that you get will be one step before the final answer will be everything in terms of theta. Then you have to convert every theta to x. For that, you have to use trigonometry and then some amount of the trig ratios. Here, the way we have shown in this triangle, how we consider adjacent over opposite equal to cotangent theta. So it involves a little amount of Pythagorean identity and basic understanding of how to write trig ratios. Hope this video helps. You may want to check my other videos in this section, which are problem number 12 and 15. Problem number 12 and 15 are done and the videos. Now let me show you one more problem here, which is number 10. Evaluate the integral 0 to 2/3, square root of 4 minus x squared. We are going to do number 10 now. In the video, you will see 12 and 15. So here, now we are going to evaluate integral 0 through 2/3, square root of 4 minus 9x squared dx. So if you notice the type that we have seen in the table, they are square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared. So if you notice here, the variable, the expression, or the coefficient of x squared is 1. In everywhere, the coefficient of x squared is 1 or negative 1. So the first step is to make the coefficient of x squared here to 1. So how do we do that without altering the expression? So it is integral 0 through 2/3. I'm going to call the given integral as I, as we normally do. Then you write here in this one, you take the 9 out. You take the 9 out. You can write inside 4 divided by 9 minus x squared dx. So how do we check what we have done is right? If you just take the expression inside the radical, it is 9 times 4 over 9 minus x squared. You distribute, you get 9 times 4 over 9 is to get cancelled out. Then you get 9 times x squared. So it is 4 minus 9x squared, which is the given problem. So it is exactly this one. So in order to make the coefficient of x squared 1, we are actually pulling out the 9. But it is inside the radical, so square root of 9 becomes 3. That can come out of the integral sign. So it is integral 0 to 2/3, square root of 4 by 9 minus x squared dx. Now, what type is this one? What type is that in the expression in the table? It is of the form integral square root of a squared minus x squared. So it is of the type a squared minus x squared. So what does that mean? A squared equal to 4 over 9 or a equal to 2/3. Because it resembles square root of a squared minus x squared, the substitution that we are going to do is x equal to a sine theta. What is a here? 2/3 sine of theta. So whenever you make a substitution, it's better. We also change the corresponding limits, just as we saw in the review. So x lower limit, and then what is the theta limit? So we have taken x equal to be x equal to 2/3 of sine theta, right? So we have to find out what x equal to 2/3 of sine theta. Then we have to come up with what the values of theta are. The lower limit is x equal to 0 here. So this is our lower limit for x equal to 0. So what does that mean? 2/3 sine theta, 2/3 sine theta equal to 0, which means sine theta equal to 0. If sine theta is 0, theta equal to 0. We are finding what theta is. Now, the upper limit for x is 2/3. Upper limit is 2/3. That means 2/3 sine theta equal to 2/3. So that will tell us sine theta equal to 1. If sine theta is 1, what is theta equal to? Pi by 2. So the lower limit of lower limit 0 of x corresponds to 0 for theta. The upper bound 2/3 of x corresponds to pi by 2 for theta. So we are going to convert the values of theta. We are going to use the new limits for theta, and we are going to convert everything to everything inside the radical to theta. So let's find out what this 4 by 9 minus x square is. 4 by 9 minus x square is. It's 4 by 9 minus x square. What is our x? X equal to 2/3 of sine theta. So that is what we are going to substitute. It is 2/3 of sine theta. That is for x. And you're having x squared, so you have to square that. That is 4 by 9 minus 4 by 9 sine square theta. So 4 by 9 is a common factor. So it can be taken out. So it's times 1 minus sine square. So 4 by 9 times cosine square theta. This is 4 by 9 minus x squared. So if I take the square root, because that's what the integrand is, if you take the square root, you get 2/3 of absolute cosine theta with our usual restriction on theta, which is from negative pi by 2 to pi by 2, then absolute cosine theta would become positive cosine theta. So the integrand is actually 2/3 of cosine theta. Then what about dx? So when x equal to a sine theta, or when x equal to 2/3 of sine theta, because in the integrand you have dx also, that also should be changed to theta. That is 2/3 cosine of theta d theta. Now we will change everything to theta and give the new limits. I, which is equal to 3 times integral. So we are actually looking at this particular step. This is our I, and we are going to change that I and write everything in terms of theta. So it is 3 times. The new limits are theta equal to 0 to theta equal to pi by 2, 0 through pi by 2. The integrand, which is square root of 4 by 9 minus x squared, from this step is 2/3 of cosine theta. Then you have dx, and that dx corresponds to 2/3 cosine theta d theta. The dx in that step corresponds to 2/3 cosine theta d theta. So one of the threes can be crossed out. So you get 4 divided by 3. 4 divided by 3. Then integral 0 through pi by 2 cosine square theta d theta. That is 4 divided by 3, integral of 0 through pi by 2. Cosine square is, whenever you have cosine square or sine square, you have to use the double angle formula. 1 plus cosine 2 theta over 2 d theta. So this is something that we mentioned in the earlier section. So now you pull out that 1/2. So I equal to 4 by 3 times 1/2 integral 0 through pi by 2, 1 plus cosine of 2 theta d theta. That would be 2 over 3. Now integral of 1 is theta. Integral of cosine 2 theta is sine 2 theta over 2. between the limit 0 and pi by 2. So it is 2/3, plug in the upper limit, which is pi by 2, plus sine of 2 times pi by 2, that will be sine pi, which is 0. Then at the lower limit, it's all 0. So it's going to be 0 there. So it is just 2/3 times pi over 2. So 2 get cancelled out. You get a value which is pi by 3. So there are several things going on in this problem. First, to identify the given integrand as one of the three expressions. After identifying in this problem, we should also make sure that the coefficient of x square equal to 1. To do that, we actually pulled out the 9, and also everything is converted to theta. Because it's a definite integral problem, the given limits are for the original variable x. Because you are converting to the new variable theta, you have to change the limits also accordingly. Hope this video helps.